So, what is blockchain? So, blockchain was actually first proposed by a couple of academics in 1991 as a way to timestamp documents. Now, that's pretty theoretical because we really didn't have the computing power on a broad consumer level to actually implement this kind of thing. And just to let you know what the situation was like back then, 1991 was the same year that the World Wide Web was turned on. So the internet became existent. And the fanciest home computers only had about 0.1% of the RAM that my iPhone 10 has. So just so you know, we weren't there yet. So it wasn't until 2008 that undocumented processing power reached the point that a mysterious figure using the pseudonym Satoshi Nakamoto issued a white paper incorporating that research, and along with others, into his idea for a decentralized and non-trust-based currency called Bitcoin. In that, in the mid-teens, blockchain's applicability to memorializing other types of data became a focus for investors, and in 2015, Ethereum became the second public blockchain. But this time, it started recording a broad array of financial instruments and also introduced smart contracts, which I'll discuss in a couple of minutes. Did I go too far? Okay. So this is what Abigail was talking about before, with the hashes and how you jump. In a more simplified, pretty way. Here's a nice little picture of how it works. So the simplified definition of blockchain is that it's a publicly accessible, decentralized, and distributed ledger of transactions stored on blocks that are chained together. So time and date stamping. But a better understanding will help you understand the many applications that it can possibly have. So that's why I would be doing this. So essentially, a user submits a transaction or a piece of data for processing and recording. We have two keys for the network: the public and the private. The private's how they access their wallet. The public is how they say, "This is my money. I swear it's mine." So it can be broadcast to the user by the nodes, which are the computers that are participating in the maintenance and storage of the chain, for verification and bundling with all the transactions into a block that's about 1 meg of data. So once a node assembles these transactions into a node, it solves the problem. Those are miners, by the way, and they solve the problem, and it produces the new unique identifier that meets the criteria with the 10 zeros. It is broadcast throughout the network and added to the chain. Everybody has a copy of the chain. Now everybody has the new block. So it links itself to the block. The data is locked in a sequence in this way, so any effort to change a block requires subsequent blocks to be changed as well. Considering it takes about 10 minutes to verify one set of transactions, this would require an enormous amount of processing power to achieve. But also, it would not match all the other nodes that have been saved, so it wouldn't be accepted in. Secure because majority rules when it comes to this process, and obtaining control of enough machines to successfully complete a 51% attack is nearly impossible. Now, in 2014, a mining pool called Gash.io briefly hit 51% control of the network. But when they discovered it, member groups that were contributing to the mining pool pulled back some of their computing power, so that they went back down to 40%, and then set up guidelines that would prohibit them from ever approaching that again. And unfortunately, they were honest nodes. They meant no harm. It just sort of happened for a few hours on a Friday afternoon, but it proved that it was definitely possible, and something that definitely one had to look out for. But generally speaking, the resources that you need to overpower the blockchain and double spend or steal coins far exceeds the wealth that you could get from doing so. And it's in the best interest of everybody to maintain the block to protect their own investments, because if you prove it can be hacked, then suddenly there's a lot less value there. So, smart contracts. The idea for those came not long after our friend blockchain in '94 and reemerged in a white paper by Ethereum co-founder Vitalik Buterin in 2013. Smart contracts work by executing a script to complete the terms set therein when the relevant conditions have been met. In fact, buyers and sellers don't even need to know anything about each other to complete a transaction, because all the terms are set in the offer and the buyer needs only to accept it to set the process in motion. Now, Ethereum set the standard in this field, but there are a plethora of others that all operate in a similar way. They are, however, a whole other can of worms, technologically speaking, on smart contracts, and I'm really glad Abby went into it, because it was way more information than I was inclined to share with you guys, because it would make your brain a little melty. So I'm including in my work site, which is also pretty voluminous, a link to an article by Block Geeks that offers a really comprehensive, like techno explanation of how smart contracts interact. So it says, it must be noted, however, that smart contracts cannot completely replace conventional written contracts, because they can only deal with the limited information available within the blockchain, which is actually a question I had for you guys, but I didn't want to get to it yet. Dealing with information outside of the blockchain is not something that smart contracts necessarily deal well with. So that is probably something that will have to be addressed at some point. I didn't really my research. So it's sort of like saying, I will sell my plane tickets from New York to Australia. It looks like the wildfires will get close to Sydney. So the system can't know that wildfires are coming close to Sydney, Australia. So it can't really, deal with the sale. Second, offers can't really be changed from submitted. So it's generally one of its selling points, but when the contract issuer has its own security flaws that allow it to be hacked, it can become a problem. A company called SmartMesh learned that the hard way when one of their security flaws allowed hackers to alter how many tokens they were willing to sell, and they lost a bunch. So I just want to note this one particular organization took the initiative to create a user-friendly smart contract system. We.Trade. We.Trade is a broad collection of institutions that brings together all sizes of buyers and sellers using an easy interface, and operates from a consortium-based platform. Let's see, I was trying to. This is quick.
Trading is part of our nature and has been, but it has always been a risky business, especially if you want to expand your business internationally. With We.Trade, we want to change that, opening up opportunities without unnecessary risk. Say two companies want to trade, but they don't know each other yet. The seller will prefer upfront payment, while the buyer wants to pay 60 days after receiving the order. So they decide to use We.Trade. Both get verified by their banks, so they know they can trust each other. We.Trade also enables them to quickly request bank payment undertaking and financing, so the payment is guaranteed to the seller, and the buyer can maintain their working capital. After the order is delivered, payment is handled automatically, and the deal is done in no time. Everyone is happy and ready for the next one with We.Trade. Do you want to know more or get started? Talk to your bank.
Yeah, this organization has been around for a few years, and they actually, as you can see, they coordinate with a lot of different international banks, and so it's a really good way for some of these for buyers and sellers that might not have interacted with one another in the past and are on a smaller level to reach out and so. Now, there are several different kinds of blockchains. Well, there's three. There's the public blockchain, which we've already discussed considerably. to the public. Anybody can read, anybody can write. It's almost impossible to tamper, relatively efficient, not centralized, and doesn't require permission. Then we have private blockchains, which one would think are the most common because they're stuff within an organization. So I'll talk about a couple later, but yeah, they are restricted, and they're only the transactions are only processed by a few assigned nodes, and they're not. They usually just cover like one particular industry, or company's operations. Then Consortium Blockchain is actually kind of the middle road. Here, let's go. So again, this is the private blockchain. So you have, and I apologize that the place I got this picture from, they don't know how to spell because member is wrong. But essentially, your private blockchain will have all these different devices and nodes in the network, and some of them will be the ones who can handle the transaction. Everybody else is just able to send or receive, but they don't get to decide what really gets included. And then blockchains are the happy medium because they cover a broad variety of companies, sometimes across industries, sometimes not. But they are run by a governance board of sorts. So you'll have several of the most trusted users who will come together to decide how it will be managed and what data is going to be included. And then many companies can access that sort of data and interact with all that good stuff. And it is a permission network, but it's much more of a democratic operation than private. Okay, private blockchain systems. So JPMorgan Chase actually has been working on this for the past several years. They are planning or operating currently several private blockchains that are in different stages of testing. Most of them are based on the same protocols. First, they have the interbank information system, which allows them to exchange information more efficiently with their other partners, so they can share transactions, that data with the company. And then to facilitate one of their primary goals, they also have created their own cryptocurrency called JPM Coin, and it's tied to the dollar, and it's a crypto that allows them to transfer money internationally without actually having to pay a ton of fees and control how they charge their fees. Right now, it's only for institutional clients, and it's probably going to stay that way. But it's for moving gigantic amounts of money. We also have Dromeus, which is designed to manage of various debt instruments like CDs, mortgages, bonds, securities, like the professor was talking about, the knowing when something has exceeded a debt equity level and calling it due. And that's also kind of in a prototype status right now. But underlying all those efforts has been their partnership with Quorum, which provides an open source solution for lots of others within the banking industry to create their own systems with all of the cost effectiveness of using an established system, but with the privacy required by the banking industry as a whole. And JPMorgan Chase is doing this kind of to put their fingerprint on the standards going forward. It has been adopted by South Africa's Reserve Bank, Brazil's Central Bank, and the National Bank of Canada. It's also the basis for Block Ledger, which is a blockchain as a service project that certifies transactions and assurance to buyers and sellers. Walmart. Walmart has partnered with IBM to create a food traceability blockchain using Hyperledger Fabric. With a more transparent food supply chain, Walmart can easily determine the provenance of food items in case of recall or other quality-related purposes. Eventually, suppliers will upload certificates of authenticity when shipping, and a new transaction is added to the chain at every stop until it reaches the store shelves. And in that way, Walmart is able to, in 2.2 seconds actually, determine exactly where something came from and where it's been along the way. And they actually touted as their big statistic that the company shortened their time to find out where a random mango had originated from 7 days to 2.2 seconds. Right now, they track some of the higher risk products like produce, meat and poultry, dairy, and multi-ingredient pre-made food like salads and baby foods. But seeing the success of tracing their own products, they are seeking to expand their processes to additional relevant supply chains across the retail industry. So in that, they've been trying to expand more consortium style of blockchains so that everybody can share in the technology of tracking their products. Additional privates include the healthcare applications where medical records can be used and shared across the medical field. You know, you take control of your own medical history in this way, and patients can fill out those forms of their medical history. Additional things that happen to them along their medical history is added in, and they and then from there it can be shared, and there's never any confusion. Doctors know exactly. People don't have to forget when they had their tonsils out. It's much easier, and Internet of Things devices can also be integrated so that data can be directly shared with their doctors. Consortium blockchains, that fun middle ground, includes De Beers. De Beers is, of course, one of the world's largest diamond producers, and they started a private blockchain to start to track the provenance of its diamonds in response to the public's concerns that some of their products were sourced from warlords and used to perpetuate conflict. Tracer, as it's known, has been so successful for them that they have expanded it to the rest of the gemstone concerns as a way to bring the reliability of the industry up for everyone. More than 30 other gemstone diamond miners have joined up in this process. So, in addition, you have MOBI, which is the Mobility Open Blockchain Initiative, which is the automotive industry's blockchain. Members like BMW, Ford, General Motors, Honda, and Renault. They, of course, use it to track where parts are moving all around the world with all of their international plants. And considering the complexity of that, blockchain is definitely a spot-on application for their use. The OOC, which is the Oil and Gas Blockchain Consortium, has the same issue. A lot of oil that comes from different places, and the resources, the flexibility that blockchain offers them is definitely something that makes their job more efficient. And then BETA, which is the Blockchain and Transport Alliance, is the largest commercial blockchain alliance in the world with over 300 members like UPS, FedEx, and Home Depot. And again, it's another logistics blockchain that helps keep all that stuff organized. Now, government applications have been some of the more exciting uses. There's an effort called Decode in Europe, part of the European Union's push to find out ways that blockchain can protect citizens' privacy while letting them participate in community, democracy, and the digital economy. And you have to think about it like this. You would probably go and complain to the city council about something being put next to you, in your neighborhood, but you just don't want to put your face on it. Well, blockchain would allow people to publicly register their sentiments without actually having to go be criticized by anybody else when they do. Canada also become a blockchain project that issued for professionals who are doing projects with them. So they have a easy way for professionals to indicate that, yes, they have actually done the job that they've done. A political party in Denmark recently conducted an internal election via blockchain just to prove its viability. And Estonia, surprisingly, has actually been at the forefront of blockchain implementation, which it's been testing uses since 2008. They created an e-Estonia program that boasts 99% of services held online. 44% of Estonians use online voting, 98% tax, and 98% of Estonians have a digital ID with 700 plus million digital signatures. 99% of their health data is digitized and stored on a blockchain. They also have the second fastest court proceedings in Europe, with the second shortest time of needed to resolve civil, commercial, administrative, and other cases. So you can see, like, the savings for these for Estonia is quite rich, and for the citizens. So essentially, blockchain is new and it holds a lot of promise, but we just don't know what all it could do for business yet. But there are many efforts being undertaken on a grand scale around the world that will suss out the best and the worst of it, and we will eventually settle into its new place as we organize and share data and trade goods in whatever ways we find most effective. You know, it's sort of like a smartphone. You know, when the smartphone was released, many asked why you needed to access the internet and take pictures with a device that's just meant to call people. And some people still do ask that question. But nowadays, most of us couldn't live without it. Thank you.